Okay, in this video we're going to continue on looking at modeling cross-level interactions in the context of a three-level multi-level model with repeated measurements at level 1. In our previous video we found evidence that percentage of full-time faculty interacted with the growth curve parameter, the slope for time predictor variable at level 1, and indicating that basically schools that had a higher percentage of full-time faculty also tended to exhibit a greater positive linear growth trajectory. In other words, the proportion of students graduating over the 11-year span within the study tended to increase at a greater rate in those schools that tended to have a higher percentage of full-time faculty. So, basically what we're doing is we're just pivoting off of the examples from our previous videos coming from chapter 6 of this book right here. So if you haven't watched any of the other videos, you probably want to watch those before you start going down this lane. So at any rate, we had grad proportion included as our repeated measurement at level 1, and like I said, we had the growth trajectory, the slope for the growth trajectory was positive and significant, and that's again indicating we have a significant increases in proportion of students graduating over time. We had our level 1 predictors, tuition and percentage financial aid. So these were characteristics of the institutions that were changing over time along with grad proportion. So we were modeling these two predictors as level 1 predictors of the proportion of students graduating over the 11-year span. Then we had the level 2 predictors, percentage of full-time faculty, and the selectivity of the institution. These level 2 predictors were predicting variation in the intercepts for the institutions, the intercepts being the initial status in terms of grad proportion. We also incorporated then the interaction terms, cross-level interactions between the level 2 institutional between institution characteristics of selectivity and percentage of full-time faculty, and the time component, the growth component, occurring at level 1. So now what we're going to do is we saw in our previous video that there was evidence of between state variation in the intercepts or the initial status when it came to grad proportion, as well as between state variation potentially in terms of the growth curves over time in terms of grad proportion. So now what we're going to do is we're going to add in between state characteristics to our model. And so to do this, let's take a look at our data set. And we have variables of average retention rate, or the average rate of retention of freshman students within the state, and also average family share, the proportion of tuition that's or higher ed tuition accounted for by families within states. So these were also centered, but you can see that both of these it's a constant across institutions within states, and then when you transition to across states, you can see that the values then vary as well. So these are basically constants within states. So now we're going to go to Analyze, Mixed Models, Linear, and we're going to continue on with our previous specification. Like I said, if you haven't already looked at the previous videos, you'll want to do that because things get pretty heady very easily. So we're going to add in our level 3 predictor of retention and average family share. And so, remember that under random, we've allowed this random effect 1 of 2. This is capturing random variation in the intercepts across states as well as the slope for our time growth curve component. So we're allowing the intercepts, or excuse me, the slope for time to vary across states. So now what we want to do is model predictors of the randomly varying intercepts and slopes across states. So that means we have to go back to fixed, and we're going to build another set of nested terms. So we're going to go to, we're going to click on average retention, click on that, by time 1, and click on that, and then click on add. We'll do the same thing for the average family share variable and time. Oops, there we go, time right there. And I completely forgot that I had not actually added in these variables by themselves. So we also need to add those in as sort of main effects, if you will. So I'm going to move average retention over and average family share over, and so that we get those components as well. So let me see if I can, all right, we'll just stick with what we have. So these two variables right here will be treated as predictors of the variation in intercepts across states, and then these two variables right here are capturing the predictive relationship between average retention and family share and the varying slopes across states. So we'll click on continue and then on OK. And as I said in the last video, as things get more complicated, it takes a little bit longer for processing to occur. So right now we're still processing, and so now you can see that we've got our estimates of fixed effects and covariance parameters and so forth. So this is the model, and you can see that we have 18 parameters that are being estimated, so hence the longer processing time. So when we look at our fixed effects, pretty much we have a large amount of consistency with respect to all of these findings right here. So when we look at our previous videos, these are all, these estimates and the significance levels are pretty consistent with what we had found previously. Now, in terms of the level 3 predictors, we have average retention and average family share. And so both of these are positive and statistically significant. And remember that these variables, these are level 3 predictors of the variation in intercepts across states. And so the intercepts are essentially going to be the initial status when it comes to the proportion of students graduating within the state. And so both of these are positive, so that's going to end significant, indicating that when states retain a greater percentage of students, freshman students, that's associated with a greater initial status when it comes to grad proportion, which kind of makes sense. And then also the average family share, the more that families, the more that they tend to, the greater the family share when it comes to the higher ed costs or expenses, the larger the graduation proportion. So you can see that, again, both of these predictors were statistically significant at that, at level, when it comes to level 3. When it comes to the interaction or the cross-level interaction between the level 3 predictor and the level 1, slope factor for time, remember that we found that there's significant variation across states in terms of the slopes for our time factor, and so we're predicting variation by modeling a cross-level interaction. So you see that when it comes to the interaction between average family share and the time 1 variable, it's negative but not statistically significant. So really it looks like that average family share is not having an impact on the change over time in grad proportion between the states. So this is not significant in the model. The average retention interacted with the time 1 predictor variable, and it's positive and statistically significant. So if we look back up here at our time 1 predictor, it's it's positive, indicating that there's a positive trending on in terms of graduation proportion over time across the states. And so in terms of the effect of average retention of freshmen, you can see that this is positive, and that just means that the slopes are becoming more positive at higher levels of average retention. So when the average retention is greater, that's associated with the slope increasing as well. So in other words, there's a more positive slope or a more positive growth rate among those in those states where the average retention tends to be higher than in those states where the average retention tends to be lower. Looking at the estimates of covariance parameters, we see that the variation in initial status for grad proportion across states is still statistically significant. So theoretically, we could add in additional predictors that may help to account for the between state um, um, grad proportion at the initial status. But we did find the time when slopes between states is not statistically significant in terms of the variation in those slopes. So we did a pretty good job of identifying a level 3 predictor of the variation in slopes between states. And then, kind of going back to our previous video, and we still see the variance in the institutional intercepts and slopes between institutions. Both of those were still statistically significant. So theoretically, we could still add in additional, level 3 predictors of the variation in intercepts. And then also level 2 predictors of variation in the institutional level intercepts and slopes. So that pretty well concludes this demonstration.